Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5. We'll present to you about Lab 4, which is discrete Fourier transform. For part 4.1 is to computing the DFT. The MATLAB function of x was written by using the DFT function. Then, the coding was saved as DFT eqn.m file to test the routine DFT eqn for each case. The first question is Sn equal to delta n. The command of n was defined as 10. After that, the command of x1n was defined. Then, the function was called to compute the DFT of the signal x1n. By using the figure command, the magnitude of DFT is plotted, while the stem command plots the discrete magnitude. After conducting the simulation, the DFT output is displayed in the command window and displayed as a metric vector form. The value of the output is equal to 1. For part B, is Sn equal to 1. The command of n is defined as 10 and the command of x2 was defined. The function was called to compute the DFT of the signal x2n. By using the figure command, the magnitude of DFT is plotted, while the stem command plots the discrete magnitude. After running the simulation, the output is displayed in the command window. Based on the command window that has been displayed, the value of k is equal to 0 and the amplitude of k equal to 0 is equal to 1. For the part C, which is Sn equal to ej2 pi n divided by n is same as the first and second cases. The value of x3 is defined and the function was called to compute the DFT of the signal x3n. After conducting the simulation, the DFT output is displayed in the command window. Based on the output that has been displayed, the value of k is equal to 1 and the amplitude of k equal to 1 is 10. For part D, which is s equal to cos multiplied by 2 pi n divided by 10. The command of x3 is defined and the function was called to compute the DFT of the signal x4 n. After running the simulation, the output shows that the value of k is equal to 1 and 9. The amplitude of the output of k equal to 1 and k equal to 9 is equal to 5. For question 3, the second MATLAB function was written to compute the inverse DFT. The coding was saved as IDFT eqn.m file to test the routine IDFT eqn for each case. The value of the inverse DFT signal for x1n is defined. By using the figure command, the magnitude of inverse IDFT is plotted while the stem command plots the discrete magnitude. The output graph that has been displayed after running the simulation shows that the value of n is equal to 10 and the amplitude of the n equal to 1 is 1. By using the same MATLAB coding, the output value of question B is displayed after running the simulation. The output graph shows that the amplitude is equal to 1. For questions C and D, the output graph that has been obtained is the same, which is the cos graph and in the discrete form.
Now I explain to you for part 4.2. On the question 1, we need to write MATLAB function of DFT matrix A. First, we declare the function of matrix A by using function command. After that, we initialize the value of n equal to 5. Then, we use for loop to generate n times n matrix. Then we run the simulation. After we run the simulation, this is the output that we get for DFT matrix. The output represent in matrix vector form. For question 2, we need to compute DFT for the following equation. First, we define the value of n is equal to 10. Then we define omega. Omega is equal to exponential bracket negative 2j times pi over n. Then we initialize the matrix of A. After that, we use for loop to define the DFT matrix. For question A, we define xn, x is equal to 1, 0, bracket 1, 9. Then we compute DFT by multiplying X with matrix of A. After that, we plot the magnitude. When we run the simulation, we get the output on the MATLAB command window. X is equal to 1 times 10 matrix with all value is equal to 1. This is the magnitude plot for DFT of delta n. As you can see, the amplitude all is equal to 1. For question B, Sn is equal to 1, first we define Xn. X2 is equal to 1 bracket 1 comma 10. Then we compute the DFT by multiplying X2 with A. After that, we plot the magnitude. When we run the simulation, we get the output on the command window. X2 is equal to, on the column 1 through 4, we get that when K is equal to 0, the output is equal to 10, while otherwise is equal to 0. When we plot the magnitude plot, we get that at K is equal to 0, the amplitude is equal to 10, while others is equal to 0. For question C, Xn is equal to exponential power of j 2 pi n over n. For question C, first we define the value of smaller n. N is equal to 0, 9. Then we define Xn. X3 is equal to exponential 2j times pi times n over n. Then we compute DFT by multiplying X3 with matrix A. Then we plot the magnitude. After we run the simulation, the output that we get on the command window is X3 equal to, on column 1 through 4, when K is equal to 1, the output is equal to 10. Otherwise is equal to 0. This is the magnitude plot for the DFT of exponential power of j 2 pi n over n. When K is equal to 1, the amplitude of the DFT is equal to 10. Otherwise is equal to 0.
For 3A, this is the analytic expression of inverse DFT matrix that show at introduction in lab sheet. For B, this is the MATLAB function for inverse DFT, which is B, and this is the command for function B. For 3C, the question want to set the result for C equal to B multiplied with A. The DFT matrix function A that get from question 1 and the function for the inverse DFT B that get from before need to compute for n equal to 5 as at line 4 and 5. For line 7 is to display the result A for n equal to 5, and for line 10 is to display result B for n equal to 5. Line 30 is the operation, then line 50 is to display the result for C. For command window, this is the result for A, and this is the result for B, and the last one is the result for C equal to B multiplied with A. Based the result C, we can observe that the value of C is 1 by in form of identity, where 1 is arranged in a diagonal form. For number 4, the function from DFT equation need to compare with DFT matrix function with the Boolean matrix function FFT. At line 10 to 30 is to define Xn for DFT equation. On line 16 until 19 is to construct the DFT function in FFT. DFT equation function and DFT matrix function need to put in FFT function. DFT equation is represented by variable A, B, C, and D as in line 22 and 29. On line 40 until 16 is for DFT matrix with A, B, and C represent. Through the result obtained, the answer for DFT equation A, B, C are the same as the answer for DFT matrix A, B, C. That's all from us. Thank you.